All right. Hello, everybody. Happy to have everybody here after a bit of a break. We are starting our next sort of series of webinars and an exciting couple of topics we have for you today. My name is Adil. I'll be your moderator, or rather a co-moderator for the webinar today. And again, I'm welcoming you all. Appreciate your time and interest in spending an hour with us on this hopefully warmer Tuesday than we had in the past. A couple of quick announcements. So as again, these webinars are stored in our YouTube channel. So please take a peek at the YouTube channel for any CMBS webinars as well. Again, as always, we always want to encourage a peer review of your respective clinical engineering, biomedical engineering programs. So if you're interested in doing some sort of a peer review, please reach out to the CMBS Secretariat for a peer review. Second is that we are in the midst and almost our finalization of our 2026 conference. So this information, I believe, should be released in the next couple of weeks, so please stay tuned. We're very excited about the location and our partners for this conference. So we're looking forward to seeing you all there. And last but not least, so last year, as part of Biomed Week, so Biomed Week happens in, I think, the last week of May, we had a Biomed promo video competition. And the Biomedical Engineering Department at the Ottawa Hospital was our inaugural winner. We'll be having another competition for this year as well. So we are looking to have everybody on the webinar and across the country submit their submissions. Again, the intent is it's going to be fun, and we'll have a lot more details in what that looks like in the upcoming days. So please stay tuned through our social media and our website. We are looking to forward and receiving all your submissions for that as well. At that note, I'm going to pass it on to Michael to introduce the webinar and our presenters.
Thank you. Yes, and as always, we really love to come to you and acknowledge this wonderful country of Canada, which really goes from coast to coast to coast. And we are a nation of nations, and it's important we recognize and remember that we are a nation of nations. So, for instance, today we come from Halifax, Toronto, and Ottawa. So I live in Kipuktuk, traditional name of Halifax, which is land of the Mi'kmaq. Adil is in Toronto, which is a traditional unceded area for the Mississaugas of the Credit, the Anishinaabeg, the Chippewa, the Haudenosaunee, and the Wendat peoples. And Marie-Ange and our two guest speakers are in the Ottawa area, which is the unceded territory of the Algonquin Anishinaabeg people. Hopefully I pronounced most of those okay. But we're very happy to celebrate our wonderful, very complex tapestry that is Canada. So today, actually, I'm not introducing the speakers. Marie-Ange will be introducing the speakers, but I'm very happy to introduce Marie-Ange. Marie-Ange is a wonderful, celebrated colleague of ours, and so she, for instance, has her certified clinical engineering and has been working in the hospital for 15 years at CHEO. Some of you may already know that she has her PhD in biomedical engineering from Université de Montréal, and before that, her MSc from University of Ottawa. So she works both in hospital and also as part-time professor. And Marie-Ange, many will recognize that she's been on with some of her students and other colleagues, especially when we celebrate Women of Engineering month in March. So without further ado, actually, no, before that, just a couple of housekeeping things. Deal and I will keep track of like the questions, which please submit with the Q&A box, not the chat box, but the Q&A box. We'll read them through the talk, and so we'll do the. Actually, Noémie, I think you're going to speak first. We'll have a couple of minutes for questions, and then wait, I think you're speaking afterwards, and then a couple of minutes for questions. So it'll be a little bit different than in the past. but we'll keep track of the Q&A. Adil and I, our ugly faces will go away, and we'll just pop up with just a couple minutes left in the talk, and then we'll answer a couple of questions, and we'll get to the next speaker. So I think with that, Maheransh, would you like to take it away and introduce our speakers, please?
Thank you, Michael, and thank you, Adele. I'm so happy to introduce the program of where the students are coming from. The program is from the Ottawa Carleton Institute of Biomedical Engineering. It's a program that offers an MEng program in concentration in clinical engineering, and it's offered in both universities of Ottawa, University of Ottawa, and Carleton University. And basically, what has this program? It has an internship that offers hands-on hospital close collaboration with clinical teams, students, where they gain practical experience with patient care. And the graduates that are here, I'm so happy to introduce Noémie, who's gonna present the evaluation of regional CMMS. And later on, we'll have Auwais Amin from the Ottawa Hospital, and Noémie Tchétchénigbo was at the CHIO Hospital. She was a student who did the internship at the CHIO Hospital. Go ahead, Noémie.
Thank you, Maria, for the introduction. I'm gonna share my screen, and please let me know if you see my screen, so I'm sure to go ahead and start. Can someone confirm that they can see my screen?
Looks good.
Perfect. So thanks again, Marianne, for the introduction. So hi, everyone. My name is Noémie. And like she mentioned, I am a graduate master's student in biomedical engineering with the concentration of clinical engineering. And today I'll be presenting a project that I have worked on during my internship at CHIO, which is the evaluation of regional CMMS. So quick outline of my presentation. So I'm going to go through the problem statement, the literature review, the methodology that I've used for the surveys and the market research, present the results, and then the conclusion along with the next steps. So first, before jumping into the problem statement, just a quick overview of what is a CMMS. So I'm sure a lot of you are familiar with this software, but for those that don't know, it is computerized maintenance management system. It is essentially a software that clinical engineers and biomedical technologists use at a hospital to really manage all different assets and work orders related to the medical devices. It can also extend to purchases, resources, and projects. And the main goal is to ensure medical equipment safety, compliance, and reliability. Now, at CHIO, we have a regional program where we are managing medical devices, but also the contracts of more than 20 hospitals in the Eastern Ontario, and having to manage multiple locations at the same time, it introduces some unique challenges specifically at CHIO. So the problem statement is as follows. The current CMS used in the regional program offered by CHIO does not include specifications that reflect the common needs of the hospitals involved. The measurable gap is the inaccuracy of the dashboard and progress reports compared to the expected outcomes of the stakeholders. So here the stakeholders will be Queensbury, Carleton, and Briere, because I was not able to do the survey for 20 hospitals in total. This matters to CHIO because it affects the ability to deliver high-quality services across participating organizations. So before getting into the methodology, I just wanted to go over the document that I really use and inspired the table that I use for the market research. So the first document was published by the World Health Organization titled Computerized Maintenance Management System. And to really summarize, it is essentially a well-rounded document that really includes all the information about a CMS, so what are the types of modules, for example, equipment types, model, location, etc. The information that really focused on that is again related to the problem statement that I read earlier is the report type. So what are the types of report that SMS is able to generate? So you can see the list below. So we have list, summary, activity. So that can be for the medical devices or for the work orders that is being done on those devices. Then we have workflow, human resources, financial, and then regulatory. The second document is also published by the World Health Organization. It is Inventory and Maintenance Management Information System for Medical Devices. One thing that I really liked about this document compared to the first one is that it really went a bit deeper on the concept of a regional CMS or also called network CMS. And I've included here in this slide a table that really does a quick comparison between a standalone CMS and a network CMS. So I'm not going to go through all the features, but there's a few that are pretty straightforward or I would say obvious. For example, accessibility and data storage. So that it will be a single location for standalone CMMS. Most likely, the data will be most likely be stored in local servers compared to multiple location and cloud centralized database. There are a few things that definitely needs to be taken into account. So, for example, scalability, cost, security is especially very important, especially for a network CMS, because with multiple locations at the same time, the volume of the data and the medical devices that we need to keep track of will significantly increase. And with that, also the number of users that we need to have access to that database will also increase. So that's why it is very important to have strong cybersecurity measures and encryption to really protect the data in the software. So these two documents that I presented are the two documents that I really, I guess, were the core of my when I reading the table for the market research. There's not a lot of research done for a regional CMS, I would say, but these two documents were enough for me to go ahead with the next steps of my project. So the methodology is broken into two parts. So the first part is evaluating our current situation. So seeing what are the features that eAutomate is lacking at the moment. And then the second part would be the market research. So starting with the first part, I've sent out surveys to supervisors and biomedical technologists in both Queenswood, Carleton, and Brea Health. One thing to mention here is that the content of the surveys is very different because the supervisors don't have access to the software directly. However, they do receive the report that we send out to them. So that's why the content of the surveys will be most likely about their satisfaction about the report. And for the biomedical technology, it will be the satisfaction about the software itself, more specifically the task that they perform on the software. So here is a quick overview of the results from the two supervisors. So you can see on the table here on the left-hand side is the list of all the multi-report that we sent out to them. And in the middle is a summary of the rating that they have gave for each one of these reports. It goes from 1 meaning not useful at all to 5 being very useful. You can see that for most of them, the answers are non-applicable. And the reason for that is either they don't receive it or it is simply just not relevant to them. The data may be accurate for these reports, but it's just not something that they absolutely need to see or is not as important as the other reports. Other themes that came up a lot in the comments were that there's a few reports where the accuracy was really low and also would not reflect the actual work that has been done, especially, for example, the first report, so matrix corrective and PM maintenance. Another supervisor has mentioned that they would like to have additional data in the report. So, for example, anything about the warranty of a specific device, or there was one that wanted to have a fiscal year based system. So instead of having, for example, the completion rate from January to December, they wanted to have a fiscal year based system. And at the end, we're both in favor of having a live dashboard and limited access to the software because, like I mentioned, they don't have access to the software at all. So that's something that they would like to have in the future if possible. The average score of all the report is 48%, which is pretty low. But there are definitely there are definitely steps that can be taken to improve the rating of these reports. Now moving on to the summary for the biomedical technologies. So 6 of them have answered the survey. And it was a survey of 10 plus questions, but there's one question that I really want to focus on today. And that is how easy or difficult it is to complete the following task. So you can see here on the right-hand side, the list of tasks that they regularly perform. So viewing the reports, opening, closing work orders, searching for information about the equipment, parts information, adding parts to work orders, etc. And I asked them to rate each of these tasks from very difficult, difficult, neutral, easy, and very easy. So when we look at the bar graph, we can see that the majority of those answers are really leaning towards difficult and very difficult. And two things that came up a lot was that first thing is that they feel like there's too many windows to open when they want to complete a specific task, and that there are also multiple ways to complete one specific task, which can be a bit difficult, especially when training a new biomedical technologist. The average score given to eAutomate as overall was 37%, which is again really low. Main contributor is, for example, the two things that I mentioned earlier, but also the fact that there are system crashes. Sometimes there is lags and sometimes they have trouble saving any updates in the software. So those were the most common technical issues and the main contributor of the low score for eAutomate. Now, moving on to the second part of my methodology was creating the evaluation grid for the market research. So I used the two documents that I mentioned earlier for the literature review to really create a long list of specifications that a regional CMS should have. Again, these specifications are not as detailed as it will be in RFI and RFP, but it gives a good overview of specific features that should be included. I've also used the multi-criteria decision making to really make sure to allocate the weight related to the objective. So the main focus of my project was regional CMMS, but I did not want to neglect the importance of having standard specification, meaning specification that should be in any CMS in general, whether it is being used for one hospital or multiple hospitals at the same time. And yeah, so I'm not going to go through all the specifications, but it's really, for example, for the standard specification, it can be anything about tracking the work orders, managing the tickets, being able to filter any specific information about medical device, and etc. And to go over a few for the regional specification, for example, one manager at one hospital should only see the data of their hospital and not another one. And they should be able to, I guess, change or save their own dashboard and report. Because like I mentioned, one supervisor might like the calendar system was just January to December for the PM completion rate, and others might like the fiscal year-based system. So I think those are features that should be included in the regional CMS so that everyone can see their own reports exactly as they see fit. So this is a overall like a table summary of the scoring for each of the CMS I've selected. So there are Mint X, eWorkorders, eMint, ClickMint, and then Limbo CMMS. So you can see for the standard this standard section, so 40%, we can see that most of them have answered 100% except for ClickMint and eAutomate. ClickMint, they didn't have any features, especially about the reporting. And eAutomate, so I have mentioned that we send out the reports to Queensway, Carleton, Bria, and other hospitals. But the reason why the scoring is low is because to do those things, we need to use a third party called Crystal Reports. So that's why the scores go up because eAutomate alone cannot do those tasks. Now moving on to the regional section, we can see that only eMint and Limbo CMS have scored 100%. We have ClickMint at 40%, same with eAutomate, and then we have Mint and Next eWorkorders. The feature that was lacking for most of them was having supervisors not being able to restrict the access of one person for them to only see data of their own hospital. So that was the most common lack in the features, especially for the regional section. And in total, we can see that only eMint and Limbo CMS have scored 100% based on the evaluation grid. So having reached this point, I have decided to go a step further and ask them for quote estimate in order to compare the cost. So after receiving the quote estimate, I did a comparison table. So essentially we have the implementation cost, which is just a one-time cost, and it's anything related to the data conversion, having access to implementation manager during the data conversion. Then there is also the monthly fee for each user and for each type of account. So you can see here we have admin, operator, mobile, dashboard. For those that there's no pricing mentioned, it's because it is if the feature was available, let's say mobile or dashboard, it was included in the already included in the flat fee that they have provided. Then total subscription is essentially the fee multiplied by the number of users for each type of account. Then annually times 12 for a whole year. And then once we add on the one-time cost, meaning the implementation cost, we have the grand total for the first year total. So we can see a wide range of prices. We have, for example, the lowest at $33,000 for ClickMed, and then we have above $1 million for eMed, which is really expensive. If we focus on the two CMMS that have scored 100% based on the evaluation grade that I created, we can see that the most CMS is much less expensive compared to eMint. I was not able to get the one-time cost from the most MMS, but even if we assume that it is the same cost, let's say $40,000 as eMint, it will still be significantly cheaper than eMint for the same capability of features that can be done with the software. So before getting into the conclusion, there's a few things that I would like to mention about my project. There are definitely some limitations. So first thing is that the sample size is really small for the survey. So I was only able I sent a survey for the stakeholders, so the hospital that had the largest volume of equipment, and also I was only able to send a survey to two supervisors, six biomedical technologists. So definitely, it is not a lot of people to send service to really have a good idea of the whole regional program as a whole. And with the limited time frame, the specification in the long table that I created is not as detailed as it will be for RF and RFP. But that is definitely like a first step just to have an idea of what's available out there and just kind of an overview of the features that should be included in the original CMMS. So naturally, with those limitations, the next step would be to perform the same survey with more hospitals that are part of the regional program in order to have a stronger consensus. And as we saw in the price comparison, it can be very expensive to get a new CMMS, but there are definitely things that can be done at the moment to, for example, improve the report reliability. So if the data accuracy can be improved, then supervisors can rely on those reports with the data accuracy, and that will definitely improve the weighting of those reports. And yeah, that's all for me. Thank you for listening.
Thank you, Noémie. That was very interesting.
Yeah.
Yeah, when I was looking at your stark differences in your numbers, both for costs as well as uptake from the text, it was
Yeah.
there's some clear trends there.
Yeah.
I'm curious if there's some hidden costs there for like data conversion and all of that. It's funny how what looks like a really good deal, but then they conveniently don't include the data conversion or you actually have to get a third party to do your mapping and all of that babysitting. Anyway, it's
Yeah.
interesting how the costs come out. We do have a couple of questions online.
Okay.
Martin Poulin, my cousin on the other side of the country, he asked, for instance, did you consider need for interface to cybersecurity monitoring software when you did your analysis?
So I did not take that into account. So my project was because I had really like a couple months. It's really just to focus on the specification that the regional CMS should include. That we might not think of for a CMS that's used only for like one hospital, I would say. But no, I did not really go too deeper to the cybersecurity and the software.
Yeah, I have to admit, I was actually thinking of a very similar question even before I saw Martin's question, because it's more and more and more you see those dashboards to track different devices that are on the network and that kind of thing. And hopefully, we get back with Biomeds working a little bit more hand in glove with our IT partners of various flavors. Um,
Mhm.
it's the only way we're going to actually keep a handle on things, so many things that are connecting onto the network
Mhm.
and have them
Mhm.
functioning well, let alone keep track of them. So thank you for that. Martin, he's a quick follow-up, couple of quick follow-up questions. Did you consider need for, no, we answered that one. Sorry, that's what re-answer this new one. Did you consider PM procedure slash checklist within software to support standardization of PMs?
Oh, so not specifically. One thing that I've asked them during the demonstration, was any if there's anything that can be, I would say, customized in the sense of, there was some software that were very like restricted, where it's like only the name, the model, the manufacturing name, and other pertaining information. But I definitely asked them for, let's say, custom fields, anything that can be customized for the hospital specifically. So I have not asked them specifically for the PM, but I took it into account in a way to see if that there could be some changes that can be made in the software related to the needs of the hospital specifically.
Cool, thank you. Yeah, when we were looking a couple of years ago at different options for systems, etc., it's the ability to have custom checklists and
Mhm.
how easy it was and how constricted your options were in attaching files to like work orders or like parent models and all that kind of thing. They were huge differentiators as to which one we were going to go with. So thank
Yeah,
you. Thank you very
yeah,
much for
and sorry, just to add a little bit, there was a few of the software also had, especially for the mobile version, those had the checklist that you can just check off and then say, oh, I completed the PM. But yeah, again, it really depends on the software. Some had it, some didn't. But yeah, it is something that was taken into account.
Very good. We'll do one more question, then we'll turn the floor over to Auwais. And again,
Mm.
if you continue to ask some questions in the Q&A, whatever we don't get to today, we'll actually pose to our speakers, get responses, and then we'll post for everyone to see the responses. So Sushita Shah, they mention, what were the challenges in the project regarding the feature patients only being able to access their data only? Close bracket.
Sorry, can you repeat the question?
I apologize for the cough.
Yeah.
What were the challenges in the project regarding the feature patients only being able to access their own data only? Close bracket.
Oh, so they were okay. So only eMint and CMS had really a feature where you can like restrict the access. So this like dashboard account, meaning that supervisors can go into the software, see that they cannot modify the data, but they can manipulate it in a way to create dashboards, live dashboard, or reports. For other ones, for example, e-work orders. They were able to do that, but it was very redundant. So you had to select the specific user, and there was like a long list of access, and you really had to check each one of them. So that can be a bit redundant. But the two other software, it was very seamless. If you select the type of account for, let's say, the supervisors, you know that supervisors will only have access to their data of their hospital and not of another one. So that was the main, I would say that was the most important feature for regional CMMS, but only a few of them were able to be able to do it.
Excellent. Thank you very much. I think what we'll do, we'll flip over to Auwais right
Yeah.
now. Thank you very much, Naomi. And if we have some time at the very, very end, after we answer some questions specifically to Auwais, we'll kind of come back and we'll do like both, maybe for the last 5 minutes. So with that, Auwais, would you like to present your screen, please? Excellent. I can see it. Floor is yours.
Can everyone hear me?
Yep, we hear you well.
All right. Thank you everyone for attending this webinar. My name is Amin, and I did my master's in biomedical engineering with concentration in clinical engineering. And as part of my degree, I had an internship at TOH, where I was able to do a project that you see here that I'll be talking about, which was about creating a medical equipment criticality assessment tool with the aim of improving maintenance completion rates within a hospital. A quick overview of the contents within the slides. I will go over the context behind me choosing this, doing this project for the Ottawa Hospital, and then I will briefly cover the difference in why the term criticality was chosen. To go ahead with the terminology of this project. I did a bit of literature review in trying to figure out the best way I can come up with a system like this that assesses the prioritization of medical equipment. Then I go over my design methodology, how I come up with the scoring framework, which then leads to my heat map visualization, as well as a test run that we did as part of my project, and some of the learnings and future work that came up as a result of this project. All right, so context, because for any type of question that we want to solve, we first need to get get an idea of what we are looking at. For a hospital like TOH, it deals with around 3,200 medical equipment models, and they could be either imaging equipment or clinical equipment, and altogether they total to around 22,000 active medical assets. And you can then picture that against the biomedical department in TOH, which has around 40 techs. And you can now start to picture this scenario which I pose here, where if biomed department has to handle X number of equipment assessment, like equipment priority, like equipment maintenance calls, then which one would they prioritize? So that was the challenge that was posed to me, and to figure out how I can come up with a system for that, and based on that, I try to come up with a system that can improve the maintenance completion rate, and as a result, improve patient safety. One thing I want to highlight before I move further is just this concept where I deliberately choose the term medical equipment when I say what I'm trying to assess here. And the WHO has a good definition for it, which I liked when I was doing this project. And they define it as a subcategory within medical devices that requires calibration, maintenance, repair, user training, and decommissioning. So these are the kind of things that not all medical devices would come under. Where, for example, something like a pacemaker or a glucose monitor wouldn't be classified as medical equipment based on a definition like this, and that just gives an idea of the types of assets that the department handles. Another point to put forward was also about the difference between criticality and risk. What I was trying to do here is not come up with the risk management methodology. Like it's not trying to figure out the risk side of things, but mostly to figure out which equipment is important if you compare one against the other. And that deals with the coming up with the terminology. Just calling it criticality is just to say which equipment would be required to get greater attention first, then subsequently others can be handled later on. And this was the definition that I came up with in the project. Is criticality is just something which defines like the importance and impact of a device on patient care as well as hospital operations. When looking at what work has been done in trying to answer this question, I found that first of all, there's a lot of literature out there, and they have taken multiple approaches at trying to figure out a way to answer this question. One of the most common approaches in this regard is to choose a multivariable model in trying to score this criticality or let's say importance prioritization for equipment. And from these multivariable approach, the variables, some of the common ones that I found were things like equipment function, safety or harm potential, maintenance requirement, the age of the equipment, and so some other variables like hazards recalls, as well as financial variables such as the cost of procurement, operational costs, and so on. What I'd really like to highlight in my presentation here is our two approaches that I looked into when trying to see what's already been out there. Is from the WHO paper, which even Noémie cited within her presentation. So the technical series from the WHO paper had two approaches that was taken to try and do something similar in this regard. One of them is the equipment maintenance number. And as you can see, this one has 4 variables that it uses to try and assess. So in this case, they call it equipment maintenance number, but the scope for this approach is to come up with answering the question for the equipment inventory inclusion. So which equipment would be included within a maintenance program of a biomed department. And to that regard, they have these 4 variables here. And another common thing that you would notice is the use of description tables like these, where each of these variables has a list of descriptions that the HTM stakeholders can refer to in scoring the equipment number for a category of equipment. And a second equation, like the second formula that was used or referenced in the WHO paper was the equipment management rating, which is this one here. And they took a similar approach to what EM number did in that they adopted the risk and the maintenance variables. But then they also introduced another variable here called the mission critical rating. And what this tried to do is the critical equipment, like mission critical rating, substitutes the function variable, which in a way to try and make a more comprehensive assessment in figuring out what's more important to the to the biomed department. And again, these two were still trying to answer the question from the perspective of equipment inclusion criteria. Another difference that you can notice from the two variables is that the variable here, like for risk and maintenance, they try to multiply by a factor of 2. What they are trying to do here is give it equal weightage to all the three variables, where each variable could be scored uh, from a score of 1, to a maximum score of 10, as it's mentioned here, and use that to come up with the final EMR formula score. Based on all the research that was done in this regard, I came up with a few guiding principles that I wanted to use when I developed my scoring system. Is some of the things that I noticed from the work done previously is that the technical data is better than having, for example, a descriptive table like the one that we saw before, in trying to remove subjectivity as much as possible. And so this could be things like if you are tracking age of an equipment. So that data is technical, as in exactly what the age is. But if I want to ask you what's the physical harm, like what's the harm that an equipment has, and you are reading off of a description table, there might be some subjectivity. And so one of the aspects was to try and minimize that. Another one was based on trying to standardize, like trying to not come up with a completely new scoring system that moves away from everything that has already been established. I tried to incorporate learnings from the Wang and Levinson paper, which came up with the EMR equation, and to try and use that within my project. And as well as because any scoring system that we come up with, it will be better to have a visualization element attached to it, so that either the biomed techs or the managers have a better understanding of what criticality, or in this case, how to prioritize equipment is, and so it's better implemented. And this was my first part within the project, is coming up with a variable selection and formula construction. There is nothing too unique here. What I tried to do was take the standard risk-based approach, where within the risk formula you have your impact and likelihood variables. I used those as my base in formulating this score. My overall score is called an equipment criticality score. And the two sub scores that I will use that eventually makes up that score is the failure impact and failure likelihood. On the failure impact side, I chose to go the same route as the EMR formula, where it had the three variables: the maintenance requirement, Health Canada risk class, and this variable of mission critical. What I instead tried to do is, because that variable was scored more subjectively within the paper itself, I tried to come up with variables in trying to model this factor of mission critical. And on this other side of failure likelihood, I chose the variable utilization rate, which was another variable that was recommended within the paper to use, as that's important in trying to figure out the likelihood of repairs, as well as another variable for failure rate. And this is the overall framework, and the difference here compared to, let's say, for example, the EM number and the EMR formula that we saw, is this one has a multiplication element in it, where and where it's introducing a dependency between the two the two overall scores, rather than just making each variable an independent factor. On the formula side, I tried to I tried to come up with the same scoring approach, where each variable is given a maximum score of 10, and that influenced the setting up of these multiplications with on each of the variables. For the failure impact, I chose the same maximum score as the EMR rating, which has a max score of 30. And the scoring ranges were developed based on taking scores from some of these variables that in the WHO paper, as well as me developing some that I will talk about in a few slides. The second variable was the failure rate formula. This one, because I modeled it using two sub-factors, I chose the maximum score range of 20, with each having 10 as usual. With the final aim of visualizing the formulas on a heat map. And because I'm going to be using a 5x5 heat map, what I had to do was normalize the scores. And so that's what the formulas here are doing, in normalizing these impact and the likelihood scores to a scale of 0 to 5. And then you multiply them based on the standard risk formula. That gives this risk score of the Fi times Fl, as shown in equation 5. This is just a summary of what the system, what steps would be taken by the department when they're trying to come up, like analyze an asset or on a model level, depending on what they're trying to score. And this would be the structure followed. I talked about model and asset level. So that had to do with what would be the lowest level of abstraction necessary in order to try and properly capture the information about these factors for an asset that's been studied. And so the scoring level of either on the model or the asset level was chosen based on that regard. The second part was coming up with description tables. I'm going to speed along this one. The main idea here was, in order to try and remove subjectivity as much as possible, what I tried to do was come up with descriptions for all the variables. And so even if I'm adopting a table from the WHO guidelines, I added extra, like the description would filling out the description so that each scoring title is clear for whoever is going to score it. And so the maintenance requirement is being scored based on the level and frequency of maintenance. Another thing I did was, in order to remove subjectivity for the physical risk factor, what I tried to do was switch it with another thing that we track in our CMMS, which is the Health Canada risk classification, as a proxy to this physical risk that a medical device might have. And it was a direct mapping between the 4 classes in my calculation. The most difficult part was to come up with scoring tables for the mission critical variable, where I had the two factors that modeled it. Was the clinical workflow criticality and the redundancy part. And I tried to do research on this based on what would be the best way in describing each of these factors, and came up with these scores, which are shown on the slides right now. And similarly, for the likelihood sub-factors for the failure rate, this was another thing that CMMS in TOH is tracking, where it tracks the average failure rate of a device in a year. using the failure codes, which was adopted in one of the white papers, if in AAMI. And so the one that we have implemented is how we track these failure codes, which would then give out the failure rates. And based on that, I came up with a description table because in this case, we are tracking it on CMMS. I chose to come up with a more granular table here, as this would be an example of as the maintenance is being done, all the data is being tracked, the CMMS can then eventually, over the life cycle of a device, analyze what the failure rate had been yearly. A new factor which we don't track in TOH was in trying to adopt this utilization rate variable. And because we don't have any meaningful way of tracking it right now, I ended up using a description table method. And in this case, in order to try and keep up the accuracy, I reduced the granularity in this case, where even if it's an approximation, you are still more accurate than you would have been if this was more granular. The third part in this project was coming up with criticality score visualization. And in this case, I used a standard risk heat map, a 5x5 heat map. And just as I used the formula that multiplies the likelihood and the impact to come up with the score, you could also use that to place the scoring that we do within on a heat map that can be displayed to the HTM stakeholders. In order to be able to do this mapping, and one other part that had to be developed was to try and come up with this transformation criteria. Since the normalized scores are continuous, I needed to come up with a way to transform them into integer approximations, and so that they can be mapped on the heat map. What I tried to do in this case was to not compromise on the risk that a device might have. And so if a risk to a device from the scoring goes even a decimal above, say, for example, this lower limit of a 1, which was here, the transformation just takes it up to a higher risk score of 2. And so in this case, when these risks do get displayed, you're not under-reporting on the risk that we calculate. And through all this, then I had an opportunity to do a test run during the project phase. I chose a set of 7 equipment models to try and see how we could implement this this model that tries to assess the criticality. And this table shows a ranking of these 7 models, where it's ranked based on that final criticality score that I was talking about before, from highest criticality to the lowest for these devices. One interesting thing that we can notice from this this approach is that even though all the scores that we give, they get placed in these grids. When you complement that with the actual score, the continuous criticality score, that gives us a better way to analyze what the criticality has been assessed to be, and in that case, which equipment is the tech prioritizing over another. And that was the main idea in developing this project, in that to come up with a way to integrate this tool within the life cycle of the equipment, where as the equipment's coming in, or if it has already been in the life cycle, let's say once this tool gets integrated, is to try and come up with a system where once an equipment is scored, everything and if it's once it's stored on CMMS, that everything is calculated on CMMS. It gives out the criticality score as well as the visualization on the heat map that can be observed by that can be used by the HTM professionals, by biomed techs in their roles within the department. Since this was a very comprehensive project, I came away with a lot of learnings and reflections on this from this system that I developed. One of them was with the fact that CMMS already tracks a lot of information about a device, such as its age, or let's say it's the asset number, where it's located within the hospital. If you can then also integrate these some of these variables that I mentioned here within CMMS as well, and so that gives us that transparency, rather than just tracking what the criticality is, but also showing what those individual scores were that led up to that score. The technologist would know what not only what the score is, but then how it came to be, right? So then they have this. There's a way to defend what the scores are, and also iterations that can be taken in trying to make that scoring approach better in the future.
Auwais, we have about less than 2 minutes left.
Yeah, sure. As well as the things. Okay, let me talk about the future work as well. The main aim here was to come up with the tool, but the actual task now of integrating this system within the department is the future work for it, as well as trying to see validate the framework, and see how the accuracy can be improved by leveraging technical data, as well as improvements that was made during the description tables that I developed, and seeing how how that can aid in improving the completion rate for maintenances. Here are my references. Thank you all for listening.
Thanks, Auwais. A very full presentation. With that, actually, I have a question and you don't have to answer on camera. I'm not meaning to put anyone on the spot. For both speakers, very, very dense with very good data. I wonder if, in addition to the recording that'll be on our YouTube channel, if we could post the slide decks for both talks on the CMBES website. So maybe we can explore that kind of behind the scenes for you. Again, there's a couple of questions that we didn't quite get a chance to get to. Auwais, I'm really happy that you put your references on your slide deck. That's fantastic. And you focused on using it to guide maintenance. I've actually used similar metrics, but different, and these look updated, which is why I'm keenly interested to guide capital equipment investment and replacement. So I think there's quite a bit to mine from both talks, even beyond how you presented it. Wonderful talks today. Thank you very much to both speakers. And Adil, I leave the final words for you.
Thank you so much. And I know there's questions, and please, if anyone has questions, please do ask our presenters. Again, I was very fascinated, very applicable, I think, to all of us in sort of a public setting that we work in. Thank you again. We'll be celebrating our Women in Engineering Month in March. That is led by our IDEA committee at the CMBES. So please stay tuned for those webinars coming as well. And to that, thank you, everybody. I appreciate your time, and we'll see you guys again Auwais and Noémie, thank you as well. Cheers.
Thank you.
Thanks, everyone.
Thank you.